Hey everybody, it is Miss Lloyd, and we are looking at inverse functions for trigonometric functions. And the first one I want to look at with you guys is the sine function. And so most often when we use these, I don't really graph these very often, and I'm starting with a graph, but it is what it is. So typically I'm trying to figure out the sine of some angle given a side. So let's say 4/5. And so I want to figure out what that angle is. And so in order to do that, I need to undo the sine and move it to the other side. So I do the inverse sine, which is also arc sine. In my calculator, this is what the inverse sine looks like. Not to be mistaken for the reciprocal. I know there's so many times when like my brain and my mouth don't really agree with each other or get along, and so my mouth will say something and my brain's like, that's not what that is. So there have been a lot of times when I've said inverse and I really meant reciprocal. Here we are looking at the actual inverses. So sine of -1 or arc sine is not the same as the cosecant. Those are not the same thing. This is the reciprocal and the other is the inverse. But we do have that button in our calculator, the sine to the negative first, which is the same thing as arc sine. So if I'm looking at the sine function itself, it kind of starts out like this, and then would go down. So there is my cosine function. Because we are wanting to make this an actual function for the inverse, we're switching the x and the y. So if we were to draw a horizontal line, this would not pass the horizontal line test. It passes definitely through more than once. So this is why we focus on just the stuff that's in between these two green lines, so that we don't have to worry about something repeating and then this inverse not actually being a function. So we have our domain that we're focusing on and our range. And notice that whenever we're doing the inverse, so if I'm doing the inverse with my students, what I typically like to do is start off with the XY chart of the original. So our sine, if I'm just looking at the stuff inside the green, and I've got pi over 2, which I know is 1. I have 0, which is 0, and negative pi over 2, which is -1. And so if I'm doing the inverse or the arc sine, the inverse means I'm switching my x and y. My x and y trade places. So I'd have 1, 0, -1, and pi over 2, 0, and pi over 2, negative pi over 2. And so it ends up looking a bit like this. And there we go. So we have our function for the arc sine, or the inverse sine if you want to do sine to the -1. We can also graph it. You could plug in y is equal to sine to the negative first of x in your calculator and see how that. Again, what I mostly use it for is just to undo the sine to solve for an angle. So then here we can do the same thing with the cosine function. So I'm going to write out the t-chart for just the cosine. And so I'm going to be in a similar situation. When we are looking at our cosine, we're using 0 to pi instead of negative pi over 2 to positive pi over 2. So remember, our cosine, we start up and kind of go down. So if we were to do the negative pi over 2 to pi over 2, we would definitely have an issue there with crossing the horizontal line more than once. So instead, we look at 0 to pi, so that we don't make that same mistake. So we're looking at 0, pi over 2, and pi. So at 0, cosine is 1. At pi over 2, cosine is 0. And at pi, cosine is -1. And so the arc cosine, or cosine to the negative first, whenever I'm just switching my x and y's, looks like something like this. And I can graph it. And then the last one that I'm going to take a look at is our tangent function. And so our tangent function, remember, it's kind of like a worm. It goes like this. And so whenever I swap the x and the y, so here my range for just a tangent would go on to positive infinity and negative infinity. So that now becomes my domain. So we can see that switch. My x is now negative infinity to positive infinity. It's going to so it'll kind of look like that. We just kind of switch it, we swap it. And typically this would be my x-axis and my y-axis if I were in the typical tangent function. And so we're looking at negative pi over 2 to positive pi over 2. So again, I'm going to start off with my tangent t-chart. And so if I'm at negative pi over 2, that's where I have an asymptote, so it's undefined there. One of the prettier points for tangent is pi over 4. We know that's at negative 1. If it's negative pi over 4. 0, we're at 0. Positive pi over 4 is positive 1. And then pi over 2 is undefined. And this is all from our unit circle. So whenever I do the arctangent, or the inverse tangent, tangent to the negative first, we're just switching those out. So that means I have asymptotes going horizontally instead of vertically, because it's where y is equal to negative pi over 2 and where y is equal to positive pi over 2 that are my asymptotes now. And then we're going along the asymptotes, but we are not touching them. And there we have our arctangent. Again, I typically use these in order to solve for something, not to graph. This is just kind of an explanation of where the domain and range come from, what we can and cannot like plug into a tangent or arctangent or inverse cosine, inverse sine, arc cosine, that kind of thing. This is just an introduction. I am going to be doing the examples with my students in class. So yeah, I hope you guys have a wonderful rest of whatever day it is. If you found this helpful, please like and subscribe. And if you think it would be helpful for someone else, then go ahead and send it on. Spread the love.